Here, next important topic is law of chemical combinations. I'll write the heading over here. Okay, there are five different laws for under this under laws of chemical combination. First law is law of conservation of mass. Law of conservation of mass. Okay, you must have heard about the law of conservation of energy, which states that energy can neither be created nor destroyed. It could be transformed from one form to another. This law statement is similar to that of only what this law state is that in all physical and the chemical changes. Okay, I'll write this law over here. In all physical and chemical changes, the total mass, the total mass of the reactant is equal to that of the product, is equal to that of the product. Now is quite simple. If I say that there is a reaction between a hydrogen and oxygen, and the product form is water. Okay, this is a simple reaction I am taking, and if I balance this, then I will balance it in this way, right? So what is the mass? If I just consider the molar masses, how they are reacting in a balanced chemical equation, the molar masses will be also same, right? Here there are four hydrogens, so 4 gram of hydrogen. Here there are two oxygens, means one oxygen weighs 16 gram, so this is 32 gram, and this should be total should be 36. So here this is 2 into molar mass or of water is 18, and this comes to 36 total. So this is also 36 in this side, in the reactant side, and the product side also the mass is same. So whatever the mass of the reactant is there, that will be the same will be the mass of the product. That is what it says. Let us take one example. Let's solve one example based on this question. Let us solve one example uh, based on this law. I'll put the example over here. Okay, this is the question which is asked. If 6.3 gram of NaHCO3 are added to the 15 gram of acetic acid solution, the residue is found to be 18 gram. What is the mass of a carbon dioxide released in the reaction? Okay, this reaction is given over here. Okay, the reaction is not complete over here. I'll just complete that reaction. What reaction it is? This reaction which is given here is product will be H2O plus salt of acetate and a carbon dioxide. The question says that if 6.3 gram of NaHCO3 are added to a 15 gram of this solution, the residue is found to be 18 gram. Means, and what is the mass of carbon dioxide release? Means this is what the residue is. Okay, this is what the residue is. So here the mass of the reactant, mass of reactant is equal to um, 6.3 gram of NaHCO3. This is 6.3 plus 15 gram, right? What is mass of the product? Mass of product is mass of residue, right? This is the mass of the residue which is given to be 18 grams, right? 18 plus the mass of carbon dioxide, that is what I need to find. I'll put this is equal to x. So according to the law of conservation of mass, according to the law of conservation of mass, the first equation is equal to the equation 2, right? So I can equate this 6.3. This is a mass of the reactant, which is equal to mass of the residue plus mass of the carbon dioxide. So mass of the carbon dioxide released will be X is equal to, uh, here this will come to 6.3 plus 15 minus 18. This answer comes to 6 and 1, 16 and, sorry, 6.3 and 15, 21.3 minus 18. So answer is 3.3 gram. So 3.3 gram of carbon dioxide will be released according to this law. Next law is law of definite proportion. Now this law states that, or also known as law of constant proportion, a given compound always contains the exactly the same proportion of elements by weight. Okay, this is what the statement of this law. This law was given by the scientist Joseph Proust. Okay, in the year 1799. Okay, if you want a photo of a Joseph Proust, I'll post that here. Just give me a second. Okay, this is what is the image. Image is available on the Google and I directly got it. I don't know how much clear it is. I'll just search for any new image. Okay, I'll take this. Copy, paste. This is okay. This is the better one. This image is better. This was a law given by Joseph Proust, Proust in 1799. This is a French chemist. And according to law, a given compound always contains exactly the same proportion of elements by weight. For example, if I take water, simple example of the water, how many hydrogens are there? Hydrogens present in this case are two hydrogens are there, right? Two hydrogens and one oxygen. So ratio of the hydrogen and oxygen in water is 2 is to 1. Now, this water, whether you take this water from any source, irrespective of the source, whether it is a tap water, right? It will, molecular formula will be H2O, number of the hydrogens and the oxygen will be in the ratio 2 is to 1, right? Whether you take a water from the lake water or a river water, irrespective of the source, okay, or it is Bisleri water, or instead of using a brand name Bisleri, um, mineral water, everywhere it will be H2O. Okay, this is what the meaning of this law is. Irrespective of the source, given compound always contains exactly the same proportion of the elements by weight, and that's it. Next law over here is a third law, and third law of chemical combinations, and this is called as a law of multiple proportion, and this was given by the scientist Dalton. Okay, in the year 1903, I guess, yeah, 1803. This year was 1803. If you see this, uh, something around after 4 years, this law was given by Dalton. uh, Law of multiple proportion. If I go by a statement, then it states that if two elements can combine to form more than one compound, the masses of one element that combine with a fixed mass of other element are in the ratio of small whole number. Okay, I will take the oxides of nitrogen. Oh, okay, oxides of nitrogen at this level. I will just write the molecular formula of the oxides of nitrogens. I will write here. Now, what is this oxide? What exactly is the oxide? You will study this in a in further classes. Now, weight of nitrogen I will write, and weight of oxygen. Weight of oxygen getting combined, and here, so here I will write certain oxides of the nitrogen. This is the oxide N2O. There is one more oxide NO. Then there is N2O3 is also oxide, means what? A combination of oxygen with some other element. So here it is a combination of the oxygen with nitrogen. This is oxide, 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 and this is next oxide is N2O4, and this is N2O5. Okay, this is the oxide. Now, what is the weight of nitrogen over here? We will keep the weight of nitrogen constant. Okay, that is what rule says. If two elements combine to form more than one compound, you can see that only nitrogen and oxygen are combining to form more than one compound. That is, uh, first compound is form is N2O, second is NO, then third is N2O3, then N2O4 and N2O5. Only two elements are there, nitrogen and oxygen. Now these two elements are combining to form more than one compound. The mass of one element that combine with a fixed mass of other element. Let's keep the mass of nitrogen fixed mass of other element, right? I'll make this 2. So what is the weight of nitrogen in all these cases? The weight of nitrogen will be um, 28, right? Over here nitrogen is again 28. Here also it is 28, 28 and 28. Now what is the weight of oxygen over here? Here only one oxygen is combining, so oxygen, one oxygen weighs, um, that is what I am saying, a molar mass of oxygen. It is 16. Here two oxygen are combining, so it is 32. Here three oxygens are combining, so 48. Then here four oxygen, so 64 I am writing. How I got this 16? 16, one oxygen. Two oxygens means 32, right? 3 oxygen means 16 into 3, 48. 4 oxygen means 16 into 4, 64. And 5 oxygen means 16 into 5, 80. Now if you see the ratio, if you see the ratio of this, ratio of what? Ratio of 16 is to 32 is to 48 is to 64 is to 18, means 16 is to 32 is to 48 is to 64 is to 80. So here ratio will be what? It is cancelling by 16. 1 is to 2 is to 3 is to 4 is to 5, right? 16 ones are 16 twos are 16 threes are 16 four. So this is what the simplest whole number ratio. Again, I will read the law. If two elements combine, that is nitrogen oxygen are combining, this is one example I have taken to support this law, to form more than one compound. More than one compounds are forming over here, that is nitrogen and oxygen, nitroxide, N2O, N2O3, N2O4, N2O5. The mass of one element that combine with the fixed mass of other element. Mass of one element I have kept fixed, that is nitrogen is 28 in all these cases, that combine with a fixed mass of other element. Okay, this is that element, and the ratios of this element is this: 1 is to 2 is to 3 is to 4, which is small whole number. Next law is Gay-Lussac's law of gaseous volume. Uh, what it says that when gases combine or are produced in a chemical reaction, they do so in a simple ratio by volumes, provided all the gases are at same temperature and pressure. Example of these laws I can give you this way. It's very simple. If hydrogen is, this is also a gas, and this law is only for the gases. Okay, the state of the react in the product should be gases, reactant, both are reacting. What you get is 2 moles of HCl. This is also a gas. This is gas, and this is also a gas. Now here if you see the ratio of this is 1 mole, this is 1 mole, and this is 2. So ratio is 1 is to 1 is to 2. Ratio of the products, ratio of the products and a reactant. So it is said that when gases combine or produce in a chemical reaction, they do so in a simple ratio. This ratio is simple: 1 is to 1 is to 2. I can take one more example. A nitrogen is there. Nitrogen. This is example one. Second example I'll take a nitrogen reacting with a hydrogen to give you a ammonia. If I see the balanced chemical equation, then this. So here the ratio is what? 1 mole. This is 3 mole and this is 2, right, of the product. So 1 is to 3 is to 2. This is what the ratios of all the reactants and product. This is the meaning of the Gay-Lussac's law. Next, fifth law is Avogadro law. Okay, we have learned this in the relationship between a mole and the volume, right? So what it says that equal volume of gases at same temperature and pressure contains equal number of the moles. See, when it comes to the gases, irrespective of the molar mass, the equal number of the mole. Let's say this is a hydrogen and let's say this is a nitrogen, and this is also, let's say, 2 moles. This is, I'll consider this is to be 1 mole. Okay, 1 mole, and this is also 1 mole. Okay, irrespective of the molar mass, they will have a volume of 22.4 liter at a standard temperature and pressure. At normal temperature and pressure, 22.4 liter. Okay, any guess whether it is a hydrogen or oxygen? If it is 1 mole, then it will have a 22.4 liter, irrespective of the molar mass. If it is 2 mole, then it will be twice the volume. So this is what the Avogadro law is. So I'll end this class over here of the all the laws of chemical combinations are done over here. Thank you. See you in the next class.